for this bit now. And, oh, it's already recording.
Just,
that's great. Thanks.
5 seconds.
Great. Now it's 10 seconds.
I just missed you catching the number of the questions. So I thought I switch it on.
That's great. That's
alright.
That little bit was great television, wasn't it?
Yeah, it was. 23 seconds.
23 seconds of rubbish so far. By which time everybody's kind of switched off and gone to watch something else.
It's another view though, isn't it?
It's what?
It's another view.
Yeah.
Doesn't mean they watched it all the way through. They will have done once they go on it.
Shall we start again? Or shall we, we'll keep going.
Yeah.
Okay.
Nearly
So
a minute.
for all those people who managed to make it through this 30 seconds of rubbish of this video, it's question 5 on the Call Forward June 2010 paper. I like doing the little intro bits. And it's
1 minute.
Implicit differentiation. Right. You know, I kind of, as I prepare students for Core 1, which the lower 6 did a couple of weeks ago, this bit of looking through a paper and working out when the paper wants you to differentiate is quite a thing in Core 1, quite a skill in working out when you have to find dy by dx. Because they rarely say find dy by dx. A lot of the time they use other ways of getting you to do it. So saying find stationary points, or find turning points, or find the gradient, or find the tangent to. And so again, it's that same thing. It's using that skill of working out when we have to differentiate. As soon as we read find coordinates of stationary points, we know we're going to find dy by dx. So we've just practiced this, we go straight into it. We're going to say it's the derivative of x squared
Find x.
plus the derivative of 4xy plus the derivative of 2y squared
1 minute comes y.
plus the derivative of 18 is 0. And as soon as I wrote that, Emily said at the front, do we have to do that? Was it not? It was you. And we don't, you know, this, I'm writing this line out to make sure I'm not going to drop any bits of it.
Can you just write like differentiation?
Yeah. And then just do it. Now, as we pick this off one term at a time, if you differentiate x squared, we get 2x. This is the product thing that we were talking about. It's 4x times y. And so when you differentiate that product, it would be the first times the derivative of the second plus the second times the derivative of the first. So that came from that one. There we differentiated the product. Now we're differentiating the y squared bit, which by the chain rule as we've just done it would be 2y squared differentiated with respect to y. That would be 4y times dy by dx. If you differentiate a constant, you get 0. And we've got 0 there. So we've got that. One little bit to kind of throw into this is you've got to be quite careful. There's a tendency for some people to think the question wants me to find stationary points. Right, I have to find dy by dx, and so they write dy by dx equals, and then start differentiating. And of course that's wrong, isn't it? Because you've got nothing to make dy by dx equal to, if that makes sense. You're not differentiating y with respect to x here, you're differentiating the whole thing. And if you do this, if you put an extra dy by dx in it at the start, then you're going to end up going wrong somewhere because it's not going to match up. So you've got to resist that temptation to, as soon as you see stationary points, write dy by dx equals. You'll get there eventually, but not straight away. We have to collect together the dy by dx terms, and so we've got, what, 4x plus 4y dy by dx's, if we add the bits together there. And let's take the other bit to the other side. We've got minus 4y minus 2x. At some point I'm going to cancel all these 2's out. And so now we get what dy by dx is equal to. It is, should we take that out now? That's minus 2 lots of 2y plus x over 4 lots of x plus y. And the question didn't actually ask us for dy by dx, but I'll cancel down the 2 there at the end. I just feel it's nice to actually give our expression of what dy by dx is. The question wanted to know about stationary points on this curve. Now, stationary points happen when dy by dx is 0. Again, we're looking back to core 1 and remembering how we define stationary points. If dy by dx is 0, then that means that this little expression here is 0. And actually, as we understand how fractions work, this expression here can only be 0 if that top bracket there is 0. It can only be 0 if that bit's 0. Because, of course, the bottom line can't be 0, because that would mean we'd be divided by 0, and we're not going to do that. So it's only that we're worried about. So we want to know when is 2y plus x equal to 0, and that's 0 if, well, how can we write that? X equals minus 2y. Okay, that's the only bit that would give us dy by dx is 0. But that hasn't told us any coordinates yet, has it? That's just told us a relationship between x and y that gives us 0. We already had a relationship between x and y that defined the curve. It was x squared plus 4xy plus 2y squared plus 18 is 0. So what we're basically saying now is that the stationary points happen when x and y satisfy these two equations. That sounds like simultaneous equations to me. And so we're going to take this equation and substitute it into this one, and that will give us our coordinates. So we sub x is minus 2y. It gives us, well, we'll be careful with this, we've got x squared, 4y squared, plus 4xy, that's 4 times minus 2y times y, plus 2y squared, plus 18 is 0. We've got a quadratic emerging now in terms of y. Okay, and so we're going to have what we're going to have. Now this is quite nice because it's just y squared terms, isn't it? We've got 4y squared, we've got minus 8y squared, so that's minus 4 plus 2. That's minus 2y squared, plus 18 is 0. So y squared equals 9. So y is plus or minus 3. We have to remember to do plus or minus there. And of course x was equal to minus 2y. So if y is minus 3, x is minus 2 times minus 3, so plus 6. So we've got 6 minus 3 is one coordinate. And minus 6, so we've got minus 6, 3 as the other coordinates. Okay, it's fine. And there we are. No, you need to go and get a jam. Just get one from T4.
Are we done?
We're done, thanks.